Introducing the basics of the software development life cycles by Team Nooblers. Kanban is important because, like other SDLCs, it is used to improve team coordination, minimize misunderstandings, and reduce delays to maintain productivity. It can be used in practice by creating a Kanban board. This can be as simple as sticky notes on a whiteboard or dedicated software. When using Kanban in practice, work-in-progress limits must be set. These limits prevent developers from taking on too many tasks at once, which helps maintain a continuous flow. Another vital part of Kanban that makes sure tasks are always flowing together instead of bottlenecking in certain areas. Kanban's task board system also helps identify inefficiencies in the development process. Its visual component is great for seeing where slowdowns in the flow are and what might be causing them. The paper I read saw the effects of switching from Scrum to Kanban. They found that it was more flexible because it does not rely on fixed sprints. Switching to Kanban also greatly decreased coordination problems because different parts of the team could work semi-independently on their own tasks. Kanban excels in environments where flexibility is essential. This makes it very good for remote or hybrid development teams where it is harder to collaborate across different time zones. Since Kanban doesn't have fixed sprint times like Scrum, release dates are less predictable. However, this problem can be mitigated by specifying a due date for critical tasks with a deadline. I chose this paper because I was interested to see how moving entirely online because of COVID-19 would affect the development cycle and how well Kanban could be used to solve any issues that arose. I was hoping to learn how effective Kanban is in a fully remote environment. So the authors think Kanban was effective because they had fewer coordination issues when the switch from Scrum was made. I agree with the author that Kanban is better for an online environment when compared to Scrum, because even though the team still meets to plan out features and tasks, Kanban is more independent, which helps with any miscommunication that occurs due to an online environment. The author's conclusion is logical because they saw an improvement in their production when they switched from Scrum to Kanban. Why is XP important? XP increases adaptability to changing requirements and ensures high-quality code through practices like frequent testing, continuous integration, and customer feedback. It's designed for rapid, frequent releases, allowing teams to respond to changes quickly. In practice, XP uses techniques like pair programming, frequent releases, and continuous integration to maintain code quality. How does XP work? XP operates through short iterations, focusing on delivering small, functional pieces with constant feedback for testing and improvement. XP reduces bugs through early testing and encourages customer feedback to keep the project aligned with client needs. So compared to other SDLCs, XP places a stronger emphasis on code quality and has a more structured approach to technical practices than methods like Kanban or Scrum. XP works best in small to medium-sized teams with evolving requirements, as its iterative process allows for constant adjustments. However, XP can be resource-intensive and difficult to scale for larger teams. I chose this paper because it focuses on a new tool designed to help improve XP by tracking and monitoring adherence to agile practices. I was hoping to learn how automation can help programmers follow XP practices more consistently. The authors believe their technique works because Eagle provides real-time feedback, which helps teams adjust their practices quickly and removes the need for manual input, reducing human error in monitoring. In what settings does this method work? The tool is particularly useful in agile teams that are following XP or similar methodologies, especially small to medium-sized teams. Do I agree with the author's viewpoint? Yes, I agree. The Eagle tool shows clear improvements in team performance, but I think more testing is needed in professional environments to fully validate these results. Finally, the conclusions are logical, but they need further validation with more testing, especially beyond the student teams used in their study. What is DevOps? DevOps is a set of practices, tools, and a mindset that combines development and operations teams to work together seamlessly. The goal is to streamline the entire software lifecycle from planning to deployment by improving collaboration, automation, and fast continuous delivery. At its core, DevOps bridges the gap between development and operations, uniting these traditionally separate teams. Hence, the Dev and the Ops in DevOps. Beyond teamwork, it offers faster software delivery, improved collaboration, higher quality, greater efficiency, and more reliable systems, key benefits in today's fast-paced tech world. Like with anything, there are some weaknesses. For organizations, adopting DevOps comes with high initial costs. Software teams adopting DevOps can be overwhelming due to the sheer number of tools and processes involved. DevOps requires more than new tech, it needs a mindset shift, with siloed teams like development and operations working closely together. This can be tough for organizations used to rigid departmental structures. Also, resistance to change is common, as some employees struggle with new roles. Strong leadership is key to guiding teams through the transition. The final challenge is culture shift. Even with DevOps in place, collaboration and trust take time to grow. I chose this paper for its focus on DevOps strengths and weaknesses in real-world settings. I aim to gain insights into DevOps as a process model and the environments where it works best. The authors used an ethnographic study with observations and interviews in 3 companies. While offering deep insights, the results aren't fully generalizable due to the shared cultural background of the companies. However, some findings align with other studies, suggesting they may apply in similar contexts. In short, the insights are valuable but should be applied cautiously to other settings. I found the author's conclusions logical. He showed that fully implementing all aspects of DevOps like automation, cross-team collaboration, and a cultural shift is essential to realizing its benefits. Evolutionary prototyping focuses on continuous development through user feedback, ensuring the final product meets expectations. Feedback is gathered and integrated throughout the process, allowing the product to evolve based on real input rather than assumptions. In practice, an early prototype is developed, tested by users, and improved based on their feedback. This cycle repeats until the system reaches a refined state. The iterative nature of this approach helps address changing requirements early, preventing major setbacks later. Compared to other SDLCs like Waterfall, evolutionary prototyping is more flexible. Waterfall follows a rigid step-by-step approach, whereas evolutionary prototyping continuously evolves one prototype. Unlike Agile, that doesn't rely on strict sprint cycles, allowing more flexibility in timing. This method thrives when requirements are unclear or complex systems need frequent user input. However, it can become costly and lead to scope creep if too many cycles occur, delaying project completion. I selected the paper on Input Gen, a tool that automates input generation for prototypes. This tool is valuable in evolutionary prototyping, streamlining requirement validation and ensuring timely development. I wanted to learn how Input Gen impacts evolutionary prototyping in complex environments, especially its role in facilitating continuous improvement through feedback. The authors claim that automating input generation reduces human error and significantly increases efficiency, making requirements validation 13.77 times faster than manual methods. I agree with their conclusions, as Input Gen effectively addresses manual input generation challenges, improving speed and coordination, while the paper's case studies support the tool's positive impact on real-time development. The reason Waterfall methodology is significant is that it employs a methodical, sequential process in which every stage, including requirements, design, and testing, is finished before proceeding to the next. Because of this, it guarantees structure and clarity, which makes it perfect for big projects with steady requirements like Nokia's 5G. Waterfall enables step-by-step implementation. For instance, software defect prediction, or SDP, helps teams efficiently allocate resources during the testing phase by identifying regions that are likely to contain faults. Waterfall ensures testing is managed, lowering risks and costs by securing requirements early. Since it detects errors early in a specified phase, Waterfall development excels at controlling complexity. Waterfall is more inflexible than Agile, which welcomes input and adaptability. It functions best when project criteria are set in stone, as they were for Nokia's 5G project. Although the rigidity may restrict flexibility, it offers the certainty required for significant projects. This study was my choice since it demonstrates how SDP enhances testing in big projects like Nokia's 5G, perfectly complementing Waterfall's organized methodology. This study demonstrates how SDP improves testing quality and efficiency inside the Waterfall approach. I was interested in finding out how early fault detection and cost reduction using SDP may enhance the testing phase. Since testing occurs after development in Waterfall, SDP is essential for concentrating on high-risk regions. According to the authors, the reason SDP functions effectively inside Waterfall is that testing takes place after development is finished, enabling targeted defect prediction. I share their opinion. The results make sense, particularly for big projects where successful outcomes depend on well-defined criteria and systematic testing.